Okay, let's take a look at writing other fractions as decimals. See, sometimes I cannot take a number and find something to multiply times it to get 10, 100, or 1,000. That is the case with 3/8. There actually is a number you can multiply times 8 to get 1,000, but you're not just going to see that. So what we need to do with this is we need to take this and put the top number inside and the bottom number outside. Because 8 won't go into 3, this is where our decimal comes in. We have to add a 0. We bring our decimal point up and put a 0 in front of it. And then 8 goes into 30 3 times. 3 times 8 equals 24. You subtract and you get 6 left over. Instead of bringing that up as a remainder, I'm going to add a 0 and bring it down. 8 then divides into 60 7 times. 7 times 8 is 56. We subtract, we get 4 left over. Still not a terminating decimal. So I need to add a 0 and bring it down. Now 8 goes into 40 5 times, and 5 times 8 is 40. So that comes out equal with 0 remainder. This is a terminating decimal, and therefore 3/8 is 375 thousandths. Now I've got something down here, and I don't remember what it is. Oh, it's just another example. I'm going to X this out so I can move it up. It'll be easier for me to do the problem. -1/40. First of all, if it starts out negative, it will remain negative. So up here in my answer, I need to make sure I put a negative sign, and don't forget it. The top number, again, goes inside. The bottom number goes outside. And because 40 won't go into 1, I've got to add a decimal point and a 0. Bring my decimal up, put a 0 out front. Now, 40 won't go into 10 either. That creates a problem. In fact, it goes in 0 times. I have to put this 0 up here over the 10 because there's got to be a number there before I can add another 0 here. 40 will go into 100, and it happens to go in twice. 2 times 40 is 80, which gives me 20 left over. I add another 0 and bring it down. And then 40, well, 4 goes into 20. 4 goes into 25 times. Therefore, 40 will go into 200 5 times evenly. And so I get 200 down here and 0 remainder. So -1/40 is -0 and 25 thousandths. Notice example number 6, 7/9. Look what happens here. Again, the top number must go inside, the bottom number must go outside. I have to add a decimal and a 0, bring my decimal point up and add a 0 to it. 9 goes into 70. What do you think? It's only 7 times. 7 times 9 is 63. And when I subtract, I get 7 left over. I add a 0, bring it down. 7 times 9, again, would be 63. I subtract, and I get 7 left over. I add a 0, and I bring it down. How many times does 9 go into 70? 7 times again. And I get 63. And then I get 7 left over. And I add a 0, and I bring it down. And it goes in 7 times. And what's happening here? Oh, yeah, the 7 is repeating. So 7/9 is actually equal to 0.7 with the bar notation. Why don't you try doing these problems on your own? Take a look at the top of page 266. Up here it says every terminating decimal can be written as a fraction with a denominator of 10, 100, 1000, or a greater power of 10. Use the place value of the final digit as the denominator. So in example 7, 0.15, the 5 is in the 100th place. That means I can write 0.15 as 15 over 100, or 15 hundredths. And you would actually read both the decimal and the fraction as 15 hundredths. Well, 15 hundredths is not in its lowest form. So what we need to do is reduce that. So I'm going to write 15 hundredths, and I'm going to divide the top and the bottom by the greatest common factor, which is 5. And that's going to reduce 15 to 3 and 100 to 20. So 15 hundredths is equal to the fraction 3/20. Now, why don't you, doing the problems down at the bottom of the page, H, I, and J?